Hi friends, welcome to all. In this video, we are going to see the lab activity, configuring and verifying Vty restrictions. Before coming to this lab activity, friends, if you are watching my channel first time or if you are not yet subscribed this channel, consider subscribing. Also enable the bell icon near to the subscribe button so that you will get the notification message when I upload the new videos. Here we can see the topology, also our addressing table. We will go through the objectives of this lab activity. In part 1, configure basic device settings. In part 2, configure and apply the access control list on R1. In part 3, verify the access control list using Telnet. In part 4, challenge, configure and apply the access control list on S1. Also, we will go through the background. It is a good practice to restrict access to the router management interfaces such as the console and Vty lines. An access control list, that is ACL, can be used to allow access for specific IP addresses, ensuring that only the administrator PCs have permission to telnet or SSH into the router. In the Cisco device outputs, ACL is abbreviated as access list. In this lab, we will create and apply a named standard ACL to restrict remote access to the router Vty lines. After the ACL has been created and applied, we will test and verify the ACL by accessing the router from different IP addresses using Telnet. This lab will provide the commands necessary for creating and applying the ACL. Here we can see the required resources for this lab activity. One router, one switch, two PCs, then console cables and Ethernet cables as shown in the topology. They given a note here. The gigabit Ethernet interfaces on Cisco 1941 routers are auto-sensing, and an Ethernet straight-through cable may be used between the router and PC-B. If using another model Cisco router, it may be necessary to use an Ethernet crossover cable, right? So this is when we use the same device, we have to use crossover cable. But if you are using this gigabit Ethernet interfaces on Cisco 1941 routers, then we can use this Ethernet straight-through cable itself. Coming to part 1, configure basic device settings. In part 1, we will set up the network topology and configure the interface IP addresses, device access, and passwords on the router. Step 1, cable the network as shown in the topology diagram. Here is our topology. We are going to build and cable this topology on our Cisco packet tracer. One router 1941. 2960 switch, 20 devices, and we are going to connect these devices using copper straight through. F0/6, F0/52, G0/1, G0/0 to this PC-B. We will rename these devices. This is PC-A. Here we have S1. Here we have R1. And this is PC-B. Also, we will label the ports. This port is F0/6. Here we have F0/5. This is G0/1. Here we have a G0/0. Coming to step 2, configure the PC-A and PC-B network settings according to the addressing table given. So coming to addressing table, here we can see the address of these devices PC-A and PC-B. Also we can see the subnet mask and the default gateway. We will copy the IP address of PC-A, and coming to PC-A, desktop IP configuration. Here is the IP address subnet to mask, the default gateway, it's 1.1. Now we will get the IP address of PC-B. Also here we can see the subnet to mask and the default gateway. Coming to PC-B, desktop IP configuration, here is the IP address and the default gateway. Sorry, it's subnet to mask. Here the default gateway is 0.1. Coming to step 3, initialize and reload the router and the switch. Console into the router and enter global configuration mode. Then copy the following basic configuration and paste it to the running configuration on the router. So we will get these commands. First we will paste it on a notepad and we will copy from here. Coming to the router R1, CLI, initial configuration dialog, no. Enable configure terminal, and here we will paste those commands. Coming to C, configure the IP addresses on the interfaces listed in the addressing table. Coming to addressing table, here we can see the IP address of each interfaces on this device R1. First of all, we will configure the interface G0/0. Here we can see the IP address and subnet to mask. Coming to R1, we will go to the interface G0/0 and we will set the IP address. Here is that specified IP address. Then the subnet to mask 255.255.255.0. Also we will give no shut command. And here we can see the IP address of the interface G0/1. We will copy this IP address. Coming to that interface G0/1, IP address, here is the address, subnet to mask 255.255.255.0. no shut. Coming to D, save the running configuration to the startup configuration file. We will do that. Copy running config, startup config. Now we will come to F. Copy the following basic configuration and paste it to the running configuration on the switch. So here those commands. We will copy these commands and paste it on our notepad. Then we will copy from here to our switch. Enable configure terminal, and here we are going to paste those commands. Next is G, configure IP address on Vlan 1 interface listed in the addressing table. Also we have to configure the default gateway for the switch and save the running configuration to the startup configuration. So coming to our addressing table, we will get the IP address of device S1 for the interface Vlan 1. Here we can see that. We will copy this address. Here we can see the subnet to mask and the default gateway. Coming to S1, we will go to the interface Vlan 1 and here we will set the IP address as specified. Here is that. The subnet to mask 255.255.255.0. Now we will exit. Before that we will give no shut command here. Now we will exit and we will set the IP default gateway. It's 1.1. Copy running config, startup config. Now coming to part 2, configure and apply the access control list on R1. In part 2, we will configure a named standard ACL and apply it to the router virtual terminal lines to restrict remote access to the router. Step 1, configure and apply a standard named ACL. Console into the router R1 and enable privileged exec mode. From global configuration mode, view the command options, enter IP access list by using a space and a question mark. We will come to our router R1, configure terminal IP access list, then we are going to put a question mark here. Here we can see extended and standard. Right, view the command options, enter IP access list standard by using a space and a question mark. Here we are going to give standard, then question mark. Here we can see 1 to 99 standard IP access list number, wide access list name. Right, coming to D, add admin-mgt. We will copy this to the end of the IP access list standard command and press enter. You are now in the standard named access list configuration mode. Here we can see how the prompt will be. So here we are going to give that a name. So that's why here they mentioned we can give a word access list name. So we given the name here. See, now the prompt is changed to config-std-nacl. Coming to E, enter your ACL permit or deny access control entry, also known as an ACL statement, one line at a time. Remember that there is an implicit deny any at the end of the ACL, which effectively denies all traffic. Enter a question mark to view your command option. So here we are going to put a question mark, and here we can see the details: default, deny, exit, no, permit, and a remark. Coming to F, create a permit ACE for administrator PC-A at 192.168.1.3 and an additional permit ACE to allow other reserved administrative IP addresses from 1.4 to 1.7. Notice how the first permit ACE signifies a single host by using the host keyword. The ACE permit 192.168.1.3 space 0.0.0.0 could have been used instead. The second permit ACE allows host 192.168.1.4 through 1.7 by using the 0.0.0.3 wildcard, which is the inverse of a 255.255.255.252 subnet to mask. Here we can see the permit command. First line, permit host, a particular host, that is 1.3. Also here we can see permit host through 1.4 till 1.7. Here we can see the wildcard given 0.0.0.3. That means from 1.4 till 1.7. So we will configure that. Permit host 192.168.1.3 permit. Then we are going to give the address to match 192.168.1.4. Also we have to give the wildcard bits 0.0.0.3. Coming to G, now that the named ACL is created, apply it to the Vty lines. Here we can see the commands. We have to go to line Vty 0 till 15, all the lines. Access class, here is we can see the our access list name, then in. We will do that here. Line Vty 0 to 15. Here we can see it's access class, then the name admin-mgt, it's in. Coming to part 3, verify the access control list using Telnet. In part 3, we will use a Telnet to access the router, verifying that the named ACL is functioning correctly. They given a note here, SSH is more secure than Telnet. However, SSH requires that the network device be configured to accept SSH connections. Telnet is used with this lab for convenience. Open a command prompt on PC-A and to verify that you can communicate with the router by issuing a ping command. So now we are going to give a ping from PC-A to our router R1. Coming to PC-A command prompt, ping to 192.168.1.1. Here we can see we are getting the reply. Coming to B, using the command prompt on PC-A, launch the Telnet client program to Telnet into the router. Enter the login and then the enable passwords. You should be successfully logged in. See the banner message and receive an R1 router command prompt. So now we are going to Telnet into R1 using PC-A. Telnet to 192.168.1.1, and here we can see it's prompted for password. Here we can see unauthorized access is strictly prohibited. This is the banner given. Password is Cisco. Enable password is class. Here we can see we able to access the router R1. Was the Telnet connection successful? Yes. Coming to C, type exit at the command prompt and press enter to exit the Telnet session. So here we are going to give exit. So we exit from this Telnet session. Coming to D, change your IP address to test if the named ACL blocks non-permitted IP addresses. Change the IPv4 address to 192.168.1.100 on PC-A. Now we will change the IP address of this PC-A. Coming to IP configuration, here we are going to give 1.100. Coming to E, attempt to Telnet into R1 at 192.168.1.1 again. Was the Telnet session successful? We will try that. Coming to PC-A command prompt, and here we are going to Telnet to our router. Here we can see a connection refused by remote host. So it's not successful. What message was received? Here we can see the message what we received. We will copy that. Here is that. Coming to F, change the IP address on PC-A to test if the named ACL permits a host with an IP address from the 192.168.1.4 to 1.7 range to Telnet into the router. After changing the IP address on PC-A, open a Windows command prompt and attempt to Telnet into router R1. Was the Telnet session successful? It should successful. We will check that. Coming to PC-A, here we are going to change the IP address. We will give 1.5 and it's in the range of 1.4 to 1.7. Right. Now we will come to command prompt and again we are going to Telnet to our router. Here we can see it's prompted for the password. Cisco enable class. Here we can see we able to access the router. So Telnet session successful. Yes. Coming to G, from privileged exit mode on R1, type the show IP access list command and press enter. From the command output, notice how the Cisco IOS automatically assigns line numbers to the ACEs in increments of 10 and shows the number of times each permit AC has been successfully matched. In parentheses, Here we can see in this output they shown that in this parenthesis two matches. So we will give this command show IP access list. Coming to our router R1, here we are going to give the command show access list, and here we can see the details. Because two successful Telnet connections to the router were established, and each Telnet session was initiated from an IP address that matches one of the permit ACEs, there are matches for each permit ACE. Why do you think that there are two matches for each permit ACE when only one connection from each IP address was initiated? Yes, here the two matches to the permit ACEs correspond to how the Telnet protocol operates while establishing the Telnet connection. The fact that there are two matches per single connection refers to how many times control information is sent to the router, generating a match to the router permit ACE. Next is how to determine at what point the Telnet protocol causes the two matches during the Telnet connection. Right here we can use a protocol analyzer like Wireshark. Okay, now we will come to H. On R1, enter into global configuration mode. Then enter into access list configuration mode for admin-mgt named access list and add a deny any ACE to the end of the access list. Here we can see the commands that we have to give on the router R1. Coming to R1, Cisco enable class, configure terminal. Here we have to go to IP access list, standard admin-mgt, and here we are going to give deny any. There is a note because there is an implicit deny any ACE at the end of all ACLs. Adding an explicit deny any ACE is unnecessary. However, the explicit deny any at the end of the ACLs can still be useful to the network administrator to log or simply know how many times the deny any access list ACE was matched. Try to telnet from PC-B to R1. This creates a match to the deny any ACE in the admin-mgt named access list. Coming to PC-B command prompt, here we are going to telnet to the router R1 192.168.1.1. Here we can see connection refused by remote host. Coming to K, from privileged exec mode, type show IP access list command and press enter. You should now see multiple matches to the deny any ACE. Here itself we can see 3 matches. Coming to R1, here we are going to give a show, so we have to exit, show IP access list. Here we can see deny any 16 matches here. Next is the failed Telnet connection produces more matches to the explicit deny ACE than a successful one. So why do you think this happens? Sure, this Telnet protocol makes many attempts to create a Telnet session, so that's why it's so. Now we will come to part 4, challenge, configure and apply the access control list on S1. Step 1. Configure and apply a standard named ACL for the Vty lines on S1. Without referring back to the R1 configuration commands, try to configure the ACL on S1, allowing only the PC-A IP address. Then apply the ACL to the S1 Vty lines. Remember that there are more Vty lines on a switch than a router. Now we will configure it on our switch S1. Password is Cisco. Enable password is class. Configure terminal. IP access list standard, and we will give the name as admin-mgt. Here we are going to permit host. We are going to permit host PC-A. We made some changes in the IP address. It's 1.5, so we will give that address here, 192.168.1.5, and there will be an implicit deny of any. Here we are going to give a deny any. Now we will exit and we will go to line Vty 0 to 15, all the lines. Access class, here we have to specify access list name, that is admin-mgt. Filter incoming connections in. Coming to step 2, test the Vty Acl on S1. Telnet from each of the PCs to verify that the Vty Acl is working properly. You should be able to telnet to S1 from PC-A, but not from PC-B. We will telnet from PC-A. Command prompt. Telnet to switch S1 192.168.1.2. Here we can see it's prompted for password. Here we can see the banner, unauthorized access is strictly prohibited. We will give the password Cisco. Here we can see now we are in the switch S1. Enable password is class. So we will exit. Now we will go to PC-B and we will let telnet to our switch S1. Telnet 192.168.1.2. Trying. Connection timed out, remote host not responding. Connection refused by remote host. Coming to the reflection. First one, as evidenced by the remote Vty access, ACLs are powerful content filters that can be applied to more than just inbound and outbound network interfaces. What other ways might ACLs be applied? Yes, ACLs can be applied to network applications like server applications also. Coming to the second question, does an ACL applied to a Vty remote management interface improve the security of Telnet connection? Does this make Telnet a more viable remote access management tool? Here one thing we have to keep in mind, ACL restrict remote management access to network devices. They do nothing to encrypt the actual data that is sent over the network. So if this information is captured somebody, then the network is not secure. Here is a third question. Why does it make sense to apply an ACL to Vty lines instead of a specific interfaces? Here the Vty ACLs are interface independent. In addition, the Vty ACL can be applied once instead of applying it to multiple interfaces. Well, that's all in this lab activity, that is configuring and verifying Vty restrictions. Friends, if you have any doubt in this lab activity, please comment below. Also, if you like my video, give a thumb and share with your friends. And don't forget to subscribe this channel so that you will get latest uploading video info directly into your Gmail. Thank you.